order of operations in 4-7 and complex fractions are rather short lessons, so we're going to take care of that. We know about the order of operations. We know we're going to do parentheses, exponents, multiplication and division left to right, addition and subtraction left to right. So when we look at this first example, we do have parentheses, so we're going to have to do what's in here first. It's a multiplication problem. I know it's going to be negative in the end. So I'm going to have a negative fraction taken to the second power in the end. And I'm going to do some canceling here. I can divide this numerator and this denominator by 2. This numerator, this denominator by 3. Now I'll multiply the numerators, multiply the denominators. 5 times 2 would be 10. And now we need to finish with the exponent. So this is really negative 1/10 times negative 1/10. Signs are the same, so it's going to be positive. We'll multiply the numerators and multiply the denominators. That's a 0. Let's look at the next one. I see parentheses, but it's just to separate the negative sign from the multiplication sign. So we don't really have any parentheses or any exponents. We do have multiplication and division, so we're going to do this first. We're going to do this problem right here, and then we'll add 1/2 to it. So again, signs are different, so it's going to be negative. And I'm always looking for cancellations, so I can divide this numerator and this denominator by 5. I can divide this numerator and this denominator by 3. And now I have 2 for the numerator, 3 for the denominator, and it is negative. And we're going to multiply it. No, we're going to add it. Sorry about that. We're going to add it to 1/2. So to add these fractions, we have to have the same denominator. So I'm thinking 6 is going to work great. Two times 3 is 6, so 1 times 3 is 3. 3 times 2 is 6, so 2 times 2 is 4. So we're ready to go. We have 3. On the top, we have 3 plus negative 4 over 6. And we have, one more negative? So this would be negative 1/6. Either written that way, or you can write it like this way where the fraction is negative. Now we have some fractions with exponents. This is 2/5 times 2/5. We'll multiply the numerators, multiply the denominators, and there's our answer. We're really squaring the numerator, squaring the denominator, aren't we? Here we're going to have negative 2/5 times negative 2/5 because we're taking it to the second power. This is going to be positive in the end, and 2 times 2 is 4, and 5 times 5 is 25. This next one, the exponent only controls what's in the parentheses. And then it's going to be negative in the end. So we're going to multiply 2/5 times 2/5, and we said it's going to be negative in the end, 4 25ths. Now the negative sign is within the parentheses. So we're actually going to multiply negative 1/4 times negative 1/4 times negative 1/4. These would be positive. The positive times the negative would be negative. Or we have 3 negative signs in multiplication, which means an odd number of factors, negative factors, is negative. Then we're multiplying 1 times 1 times 1. 4 times 4 would be 16 times 4 would be 64. The last thing on this page says we're going to evaluate algebraic expressions. 2 divided by y, this is y, times z. So we have 2 divided by negative 14 thirds times negative 1/3. Now we have division and we have multiplication, and we're going to do the multiplication and division left to right. So we're going to do this first. We know this is 2 over 1, and instead of dividing, we're going to multiply by the reciprocal, so we're going to flip this one over. So we have 2 over 1 times negative 3 over 14. I'm looking for things I can simplify, cancel, and I can divide this numerator and this denominator by 2. So I end up with negative 3 over 7, and I'm going to multiply that by negative 1/3. Signs are the same, so it's going to be positive. And now I can cancel. I can divide that 3 and that 3 by 3. And I end up with 1 times 1 is 1. 1 times 7 is 7. Positive 1/7. Now we're moving on to complex fractions, which are really just a different way of writing things that we already know. A complex fraction is a fraction in which the numerator and the denominator contains one or more terms with fractions. And we know that this fraction bar means division. So really, it's just a division problem, isn't it? This is really x over 4 divided by 3/2. That's what this means as far as doing any computation. So we're not going to divide. We're going to multiply by the reciprocal. And now that I'm in multiplication, I'm always searching for cancellation. So I can divide this 2 and this 4 by 2. And I have x on the top and 6 on the bottom. The other problem that we have here is a complex fraction because it has fractions on the numerator, fractions in the denominator. And we know that this fraction bar is a symbol of inclusion, like parentheses. So we're going to have to figure out everything on the top and divide it by whatever everything on the bottom comes out to be. So we're going to have to add on the top. We're going to have to divide on the bottom. So if we have 1/2 plus 3/8, we need a common denominator, and I can use 8. So 3/8 is already done for us. To go from 1/2 to 8 would multiply by 4, top and bottom. So we have 4/8 plus 3/8 would be, 7/8 for the top. And on the bottom, we have 3/4 minus 1/6. We do need a common denominator and cannot use 6. I'm thinking 12. So to change fourths to 12s would multiply by 3, top and bottom. To go from 6 to 12 would multiply by 2, top and bottom. So we have 9 12s minus 2 12s, which would be 7 12s. So now we have a problem that looks like this, and we know that would be 7/8 divided by 7 12s. When we're in fractions, we don't divide. Instead, we multiply by the reciprocal. So 7/8 times 12 over 7. Now I'm in multiplication, so I can cancel. I can't cancel until I get here, but I can divide this numerator, this denominator by 7. This numerator and denominator by 4. And I end up with 3/2 or 1 1/2. Either one of those answers would just be dandy.